these are my synths. Actually, you can't see the other one. There's two synths here. We're going to start with this top one. A synthesizer basically takes some oscillators rather, and mixes them together, filters them, and makes sound. So when I click these notes, you hear sound. There's a bunch of knobs, you know, like I can turn this knob on, and now when I click the note, I don't have to hold it. So like a bunch of settings of various kinds. We'll talk about some of them. I want you guys to ask questions and just interrupt me, like yell into the mic so I can hear you, and ask lots of questions, please. But before we get into the code, I want to give you the idea of like what even I did with this project, because the synthesizer here I just bought from Korg. The lights, however, I put on top. They're these, I forget the exact like model of them or whatever you call them, the part number, but they're these really cool addressable lights, so you can make them do different things. Like each light has its own value. And then there's a box over here you can't really see where I plug in an output. So let me show you a little bit better. If you can sort of see over there that box dangling on the side of the synth, that has a 3.5 millimeter jack input, and that's the entire interface for this thing, input interface. The output interface for the thing I made are these lights. So there's this little wire that goes up to the lights that controls them. So I'll talk about what they do. Let me share my screen. And I can share this URL with you guys later, but here's a little picture of it, basically going through the code. This is written as an article you could kind of read. It's a work in progress, so I'm going to skip down to the relevant part. I might have to reorganize this at some point. But basically, so there's the strip of LEDs, right? And I think there's 28 of them. What's 28 divided by 7?
9? No.
Anybody, please?
Are you talking about 4?
It's 4.
4. Okay, good. So there's 28. There is, in fact, 28 LEDs because I know there's 7 bands. Here's the 7 bands. So there's this chip. It's called the MSG EQ7. It looks like that little thing. It's on the board, and it has 7 bands. It's an equalizer. So it's really an analyzer of the sound. So here's the frequency response for each of the bands, and they look kind of the same, which is good, but they're centered at different frequencies. So if you just look at this 63 hertz frequency, this is saying if the input from the 3.5 millimeter jack is at 63 hertz, it's going to pick up this much of that signal around. Like, I'm not describing this very well. This is the frequency spectrum, right? The first band of this thing, which is the first 4 LEDs on the left here, is going to be brightness controlled by this band here. You can see my cursor, right?
Yep.
Yeah, see the cursor.
Cool. So if I have a really strong 63 hertz signal, I'm going to see a really bright first 4 LEDs, and the columns are all the same. So to demonstrate this a bit, if I play a note, you see there on the bass, it's almost flickering a little bit. You can see they're all kind of lit up. You might be asking, why are they all kind of lit up? Well, that's because there's actually components of a lot of the frequency spectrum in this one note. Even if I change the note, you can see, like, yeah, okay, I've lost some of the bass, but there's still a pretty broad spectrum here. Let me turn the hold on so I don't have to keep clicking the notes. I'm just going to play A. And now I've got these filter knobs. These are what's fun, because filters filter the frequency spectrum. So I got A playing. I can filter out the low end. This is a high-pass filter. Or I can filter out the high end. This is a low-pass filter. And you can sort of mess with it, like I wish I had a picture of the frequency response of these filters, but there's basically, if I go back to the screen share here, these are peaks, right? These peaks. So on my synthesizer, I can control the peak of these frequencies filters. So you can see here when I adjust this other knob, that peak actually gets brighter. And you can make some pretty weird sounds. Like when I just mess with the high pass, it sounds like this, right? Not super exciting. But when I put the peak on there, it sounds like this. And it's fun to watch. Any questions so far?
Oh, that's pretty cool.
Reminds me of Doctor Who. The noises, that is.
No questions. All right.
I have a question.
Sometimes you get in weird
you said
resonance.
there's just a 3.5 jack inputting into your Arduino device.
Yep, that's
Right.
the entire interface.
So if you were to like plug like a line out and listen to people's voices, would it also have all of those different spectrums in it? All those components?
Oh my God, you're a genius. Hang on. Okay, so this microphone line out. Yeah, let me just plug in. This might be a terrible idea. Because I can just plug in the speaker from my Mac into it, right?
Well, you know what it's like coding on the fly? I think hardware changes on the fly is probably even worse.
Yeah.
Good luck.
Where's my cable? So here's the cable. So now it's just loose, right? Now it's just loose. I can like tap it with my finger and it's doing whatever that is. I'm going to plug it directly into my Mac.
Waiting for Nate's
Okay.
office to explode.
And now I'm going to switch my audio output to external headphones. And somebody say something?
Hello?
Hello.
Hello? Yeah, it's lighting up. You can tell what the delay is.
I don't know if you guys can still hear me. It's not working for me because local, but
Yeah, we can hear it. You can't hear us.
You just
and I
gotta
also
look at the
can't hear you
lights.
guys.
The
So
light
I'm
flickers.
gonna cut in here
You're
in like
talking.
10 seconds. Right. I know you guys can hear me. I
Yeah.
assumed that anyways, but all right. That's fun.
Can you hear us now?
Yeah. Yep.
Yeah, we were
All right,
making the thing go with our
Okay,
buttons.
well, so now we can just hop over to the next thing. I had this wire here plugged directly into the synth's like signal out, but I'm just gonna plug the mixer in to the box now so that other synths and stuff work. Does it work? Of course it doesn't work because I don't have the headphones plugged in. There we go. All right. Anyway, let's look at the code. So basically, this actually isn't quite the code that's on there at the moment. I discovered I had some uncommitted changes, and they're sort of irrelevant. Basically, I put LEDs all down the back recently, and I want to make it so that like the top does what it does today, but the back flows like every second or every half second. It shifts down one row, so you can kind of see like an actual spectrograph, which is mostly. I think the code kind of works. I don't even know. Anyway, and there's some features in here that I don't use, like this green and blue stuff isn't currently being used. I don't know. These are RGB LEDs, but I think red is just cool. So these are all just the configurations. This is C++ essentially with this library and Arduino stuff. But I'm using like some of these values here as like Boolean configuration flags and some enumerations and configurations for like what pins things go to. Because with an Arduino, right, like all these pins, these are just digital or analog inputs or outputs. So you have to configure like, okay, I've got my display wired up to Mosey, which is pin 5. All right. So I don't think this is all like the mappings here get confusing. You have to just look up data sheets and stuff. I made it configurable for the number of bands, but the chip I'm using only has 7. So these are all just static variables, like constants, macros even. And then this is like the main interface. We're going to ignore the color stuff because, again, I'm just using red, so this isn't all that interesting at the moment. But this stuff is good. So basically, you can think of this as we're going to read in the values from the analyzer chip. It's like a Fourier analyzer thingy. You can think of it as that those 7 bands gives me an array of 7 values that are integers. And this, you're thinking like, okay, well, this is an argument, not a return type. I have to allocate the array ahead of time, and just we're going to edit it because every like iteration of this loop, I'm only dealing with one analysis point. So rather than dealing with allocating memory or anything, I just have an array of 7 length, and I keep it up to date at the right times. Not functional programming. Update display then takes in something that is an array of arrays of display depth, which is like the number of rows, and then the bands. So you can basically think of this as a way. If I wanted to not have the history feature where it sort of flowed over time and all the rows were the same, which is what it's doing right now, I wouldn't really need this display depth thing. And I could just have the bands, and it would the update display function would just loop over the depth statically. But because I want to leave the option open to make each row different, I'm actually allocating a larger array here and using that. And then I'll explain these in a second. I'm gonna have to think about these a little bit. But does the general like high level read and update make sense to everybody? Anybody have any questions?
Imagine you're going to put them in a loop. Is that right?
Yep.
I think it makes sense.
All right. This Arduino is operating at like 16 megahertz, which roughly means each instruction goes like, however many clock cycles per instruction. But give you a sense of how quick. There's not a lot of performance in the actual hardware, but it's doing so little that it updates quickly. Okay, so then we allocate, like we set up the display. This is the display interface. If we have time at the end, I'll explain better what this is doing. It's actually kind of interesting. Setup stuff, just like setting the modes for the pins. Pins can be inputs and outputs. You got to set all this stuff. This is like a debug interface for print lines, all this setup stuff, nothing too interesting. And then it's pretty simple, the loop. We allocate the spectrums. That's the only like statically allocated, array. We read into the first spot of it, the current value of the like analog signal. And then depending on if we're using history or not, we're not using history. I'm not going to get into shift too much right now. We just clone that spectrums thing through the entire depth of the display. That's what clone does. Just takes the first element and copies it into the rest of the array. And then we update the display. Right?
So, Nate, question. Is loop, is it being driven by some framework that's going to call loop on some regular cycle?
Yeah. This is where Arduino is like, this is one of the main things of Arduino. If I go to the C code, which is like sort of a work in progress, like instead of saying pin mode, you do something like this. And then, so this is setup and this is loop, right? This is C, like nonsense for, well, because like, normally you'd have a for loop with like the initialization, the condition, and the post condition or something. And if you want to just loop forever, you do that. So anyway, yeah, Arduino has a little bit of a framework. Okay, let me talk a little bit about read MSG-EQ7 because this is cool. Because the data sheet shows you this diagram, which is a timing diagram.
10
And the time.
minutes.
Oh wow, we're not going to actually play very much music. I was going to explain like what attack and decay and sustain and all these filters were, but whatever. The timing diagram here is pretty cool because it tells you exactly like, all right, it needs to be in this. These are the pins. There's 3 pins for the for this chip. Right, here's the chip. There's some grounds and stuff, but like there's 3 control pins that go to the Arduino. So the Arduino needs to do the right thing with these logic levels, which are digital. And so it's reset, strobe, and output. Basically, the output is going to be what tells you. Actually, it's been a little while since I read this. I'm not going to dissect this for you completely. You should just read it and try to understand it. I should have prepared a tiny bit better. But you can see these time ranges here, like TR, TS, TSS, are giving you the distances between clocks or signals. And you need to map that to delays in your code and places where you actually read the right thing. So essentially how this works is you're going to have a value, an analog value, that you can read with a analog to digital converter, which the Arduino has built in. And basically at the right times, you have to read the value. So the chip says, okay, first we're going to read the 63 hertz section of this thing. First, we're going to read this part of the, what's it called? Analyzer. It's right. So
Wavelength. I don't know.
What?
I mean, it's called like a wavelength, but yeah, keep going.
Yeah. First, we're getting the 63 hertz centered like value, and then at that point, like for this time period, we can read that value. So we're only getting one of these like centered analyses at a time. Then we say, okay, well, we got that one, so we can strobe. We'll send a signal to say, okay, move on to the next one. And then we read that one, and then we move on to the next one. So we actually aren't reading the entire signal at once. We're reading it so quickly, within, what are these? These are microseconds or nanoseconds for some of these even. We're reading the signal so quickly that it kind of almost is like we read the whole thing at once. But you can't actually, with the way this chip works, and I think sort of in general, you can't read like 2 of these pieces of the signal at the same time. Did that make sense? I feel like I didn't explain that great.
It does. Basically, the signal is serial, right? So you need to like read one value at a time.
Yeah.
I was gonna say, is it kind of like it takes like a snapshot of all the wavelength, and then it kind of like separates them into these each? Like,
no,
okay.
It's exactly not that.
Exactly.
You can't take a snapshot of the entire like wavelength. It has to look at the 63 section first, then the 160 hertz section, then the 400 hertz section. But
so the chip is actually sampling different levels when you tell it to do so.
Exactly. Yeah, sampling.
So do you miss some of? I know you're saying it's so fast that is it possible there might be some loss of capturing some of those frequencies?
I don't know if I'd even call it loss but there is like a delay. In theory, not in theory. The like high end, for example, this 2.5 kilohertz section like the sampling of the 2.5 kilohertz section happens some like some 100 or 200 so microseconds after the 63 hertz section. So if you've got some music that's like designed for aliens that can hear down to the like microseconds, sure, they might complain that this doesn't work very well for them. And then I'm not going to get into the update code for the display. it's kind of interesting. I want to like show you a little bit more of the synth in the last 5 minutes here. So if you have any more questions, just holler.
Did you actually have a delay in the update for the display? You said that the lights were flickering a little bit. So if you don't have a
What do you mean
delay,
flickering?
like we see the LEDs flicker. I don't know if you see that or if that's just caused by the camera.
Oh yeah, let me explain that. So here's what it looks like with one oscillator, and you can see it's flickering a little bit. That's because this oscillator has some like weird resonance and harmonics and stuff in it. If I turn on another oscillator, you can hear that's pretty in tune. But if I shift it out of tune, you can like hear those beats. And you can see the beats. That's the two oscillators not being in tune with each other.
You mean in phase?
No, in tune. Like I'm shifting the pitch. Yeah, in phase, sort of. But like if you've got two pianos and they're not in tune with each other, that means like the A note isn't at 440 hertz on both of them. Then they're gonna sort of get off, and then you can actually hit like a what's it called, a harmonic, where they get back in tune. So these are detuned to each other, but they kind of line up.
Is that what it means to be like an octave apart?
An octave apart is in tune. It's not even hitting a harmonic. It's just like in tune.
Oh, okay. 5 minutes.
I was gonna set up the sequencer, but I'm not gonna have time. Oh, the lights have frozen. I'm having, okay, so this is the last thing I'll explain with electronics, other than that it's really just fuzzy and everything kind of works or breaks randomly. I think when I added the back panel, it's drawing so much power sometimes that it browns out. And a brownout is essentially like you're just drawing enough power that chips, whatever chip it is, it's probably the Arduino itself, just doesn't quite have the oomph to drive all of the other chips that it's controlling. And it's probably a clock signal that gets out of whack and the whole thing just goes bonkers. I don't know. You don't want brownouts. You typically test things under load and figure it out. Or you could do the math. I didn't really do the math on this one. I just started adding lights. The solution's probably pretty easy. I don't really know though. So haven't gotten that far with the prototype. Probably have to do the math, you know. Easy solution though. And it works again. All right, thank you. That was my tech talk.
Cool. Anybody have any questions?
Yeah.
What kind of Arduino were you using for this?
SparkFun Arduino Pro Mini. Oh, I didn't even show you guys. I was gonna show. We like. Oh my god, it's so great. We like built a board. Oh man, I don't know how to show. Wait, hang on. So many cameras and stuff. Now, is it only coming out of one mic, or is my microphone or my headset broken now?
We can hear you. I can tell you that much.
Okay, it's only coming out of my right ear now. Whatever. Anyhow, we printed a board. we etched this with chemicals. We like, this is like darkroom photography style stuff. It kind of works, but yeah, like etched it with ferric chloride and other ingredients. So it's kind of fun.
Is that where the analyzer chip is mounted onto the board, and then the 3.5
Yeah, so you can
jack is on
see.
there?
Yep, there's two chips that are kind of the same. They're DIP 8s. One of those is the MSG EQ7, and one of them is the AT Mini, which is not an Arduino. Arduinos are just AVRs. So it's an AVR that's like called the AT Teeny. I think it's also 16 megahertz, but no, it might be 8 megahertz. This is why I had to rewrite it in C, because that library, that Adafruit library, doesn't work with this chip. And then this thing here. Oh my god. This thing here is the power thingy. So that's basically it. You got power. You got like the microcontroller and the analyzer sampler thingy, a reset button, some other like ports and stuff, and it takes a surprising amount of wiring. What's up? Sorry?
Did you do the board design with Eagle, or what software did you use?
KiCad. It sort of sucks because KiCad changed version, and my old project, just like all the libraries are different and all the names changed, and so all the symbols are remapped. So I just have a PDF at this point.